So we've talked the domain is the possible x values and the range is the possible y values. So I'm going to do all of these on what says worksheet number 8, the second page. Right, and we're going to go through. All of these ask you whether the graph is a function or not. So how do you tell something's a function?
Vertical line test.
Vertical line test. Then you're going to get the domain and the range. And then on the back of this, we're going to practice with some function values when you're given a picture. You guys are really good at function notation to substitute it into an equation, but then sometimes if you're given a picture, you can confuse out what you're trying to accomplish. All right? So on number 1, is this a function? Yes. Right? Vertical line test passes. What is the domain of number 1 going to be? All real numbers, because there's arrows at each end. Right, so it's going to keep going, so every x value will be used. What is the range going to be? What are the possible y values?
Whatever that number is,
3 and -3. So you can write that -3, 3 using a y, or you can use set notation. I think that we did set notation earlier this week, and we said there was going to be a range or a domain or something, and there was one value not included, and I used an intersection and I used an and. It would have had to have been an or. It had to be a union, because you want to join those two together. I just put the wrong symbol, if anyone was wondering. All right, on number 2, is this a function? No. What's the domain? -1 to 9. Again, make sure you're using an x for domain. You could still use set notation if you want to. What about range? 1 to 5. Is number 3 a function? All right, and what's the domain? All numbers, because there's arrows, so that means it's going to continue. What about the range? -infinity to 3. So all y less than or equal to 3, or you would put from -infinity to 3. Make sure you use parentheses with your -infinity. Questions on 1, 2, or 3? I have to clear these as I scroll down. Sorry. All right, on 4, 5, and 6. Is 4 a function? Yes, that's just a linear function. That's not a big deal. What's the domain for a linear function? All real numbers. And what about the range? All real numbers. So then on number 5, please notice that none of these are combined. Like there's nothing connected. You just have a bunch of points. Right? That's important. Is it a function?
Yes.
Does the vertical line test pass or fail? So then it is a function. For the domain, how are you going to get the domain? You'd have to give the x value for each individual point, because that's what it is, right? It's all the possible x values. So I'm going to go from left to right. So what is the x value here? And then what about here? What about here?
3.
And then here. And then here. Right? It's just the set of x values. What about the range? Same thing, it's the set of all the y values. So -3, 0, 2, 4, and 6. Right? These have the same y value, so you just include it once. Questions about that? On number 6, that is connected. There is a line there. Is that a function? What is the domain? -5 to, I think it's 4. I know it's hard to see. What about the range? Right, all the y values are going to be at 6. Questions about those three? All right, 7, 8, and 9. Is 7 a function? Yes. What's the domain?
All real numbers greater than -5.
Yeah, just greater than, right? Not greater than or equal to. And then what about the range? All greater than, yeah, both by 3. So far, so good. What about number 8? Is that a function? All right, and what is the domain? Two. Greater than or equal to 2. And then what about the range? All right, one more. Is this a function? No. And so what's the domain? The -1. What about the range? Right. And the bottom one is -6. Questions or any of that information comes from? All right. Then the back of that page. In this case, you guys can do function notation. If I said find f of 0 and I gave you an equation, you plug the 0 into the equation and you get a number. No big deal. But then if I give you a graph, people get confused. So we're just going to go through this real fast. All right? All this is saying is it's saying if x is 0. That's how you would treat this if you had an equation, right? You would put the 0 into the equation. You just don't have an equation, you have a graph. So you're just finding out what the y value is when x is 0. So if you look at the graph, when x is 0, what is y? 2, right? There's a point right there. Does that make sense? Does it make sense to everyone besides Brandon? All right, on B, what is f of 1? When x is 1, what is y? 0. When f is -5, what is y? -4. When f is 3, what is y? When x is 3, what is y? There's nothing there, right? So that means it does not exist. Don't try to make something up. There's nothing there. What about when x is -3? -1. What about when x is 5? -8. What about when x is -2? -1. What about when x is 6? 8. And then I'm going to add another one, just for argument's sake. What happens when you're looking for f of 4? False. So if x is 4, y is -5. So be careful, right? Because a lot of you said there's nothing because there's an open circle. That would be correct if nothing else there. But there happens to be a point down here at the bottom of the graph. Okay? If you had just done like 1, 2, 3, 4, 5, 6, f of -6, that's right here, then it would be does not exist because there's no other point on the graph. I did try to trick you and I succeeded. Questions about any of the things we've done are covered today. These are things you've looked at in the classes, but I still have times where people get confused. Like, for example, the one there's a bunch of points, right? What's the domain and range? There's a bunch of points. Okay, it's just because we haven't really talked about it. So we'll make sure we all look at them, make sure we know what we're talking about.